Wow, crayfish, wow. When word first spread that Australian farmers were dumping millions of crayfish into their rice fields, it sounded like a joke. Headlines mocked the idea, critics called it desperate, and social media turned it into a meme. The very notion of combining crayfish farming with rice paddies seemed absurd. What was next? Kangaroos and vineyards. But just a year later, the laughter stopped. The results weren't just promising, they were groundbreaking. Yields soared, profits doubled, chemical use dropped dramatically, and ecosystems began to recover. For the farmers who took the leap, the message was clear. A new chapter in sustainable agriculture had begun. And it all started with a move that seemed ridiculous until it worked. Why move crayfish into rice fields at all? The answer lies in a crisis. Australian rice farmers were facing a perfect storm of challenges: declining water allocations, falling prices, and increasing pressure to reduce chemical inputs. In places like the Riverina, once thriving rice fields were being abandoned. With climate variability and tighter regulations squeezing the industry, it became obvious that innovation was no longer optional, it was essential. Enter the crayfish, specifically Cherax quadricornatus, or redclaw crayfish, a native Australian freshwater species known for its rapid growth and high protein content. Traditionally raised in tanks and ponds, redclaw had never been part of rice farming, but across the ocean in China, a quiet revolution had already proven that this combination could work, and work brilliantly. In Chinese provinces like Hubei and Jiangxi, the rice crayfish farming model had become a success story of epic proportions. Millions of hectares were converted into aquatic agricultural hybrids where rice and crayfish flourished side by side. Yields rose, chemical use fell, and farm incomes soared. The model was so effective that it lifted millions out of poverty and became a symbol of sustainable farming, eventually being adopted by countries like Vietnam, Thailand, and parts of the US and Australia took notice. Scientists at CSIRO and Southern Cross University began asking a bold question: could this work here too? They studied the biology, the water systems, and the local crayfish genetics and found that not only could it work, it might thrive. Redclaw crayfish naturally feed on detritus, weeds, and pests, reducing the need for chemical inputs. Their waste acts as fertilizer, their movement aerates the soil, and their presence adds a second revenue stream for farmers. Still, critics had valid concerns. Could crayfish burrow through levees and damage infrastructure? Might they spread disease or disrupt native species if they escaped? Would traditional farmers embrace such a radical change? Despite the doubts, pilot programs were launched in select regions. Tens of thousands of crayfish were introduced into controlled rice paddies in an effort to replicate China's success in an Australian context. At first, many saw it as a long shot. But when the first full harvest came in, public opinion began to shift. At the core of this transformation is a principle from nature called mutualism, a relationship where both species benefit. The rice and crayfish form a miniature ecosystem. The rice provides shade and a cooling canopy, protecting crayfish from predators. The crayfish, in turn, forage for pests, stir the soil, and release nutrients through their waste. This natural tilling boosts soil health, promotes deeper root growth, and reduces the need for synthetic fertilizers. Crayfish droppings are rich in nitrogen, slowly releasing nutrients into the water and cutting chemical runoff. Studies have shown that methane emissions, a major concern in flooded rice fields, drop by up to 40% in crayfish integrated systems. Nitrous oxide, another potent greenhouse gas, also declines thanks to reduced fertilizer use. There are other benefits too. Crayfish eat mosquito larvae, snails, and rice plant hoppers, reducing the need for pesticides. In many trials, farmers used up to 60% fewer chemical inputs. Water use becomes more efficient as well. Instead of draining and reflooding fields, which consumes large volumes of water, crayfish fields are maintained at stable, shallow levels. This consistency helps conserve water, protects crops during heat waves, and doubles as habitat for the crayfish, eliminating the need for separate aquaculture or infrastructure. Perhaps most surprising is how the rice itself responds. With less stress from pests and weeds and a more nutrient-rich environment, rice plants grow stronger, more uniformly, and produce higher yields. This isn't just a clever trick, a rethinking of agriculture. Modeled after natural systems, it combines ancient wisdom from polyculture farming in Asia with modern ecological science, and it diversifies risk. Even if rice prices fall, crayfish remain in demand as a sustainable low-carbon protein source. Farmers now harvest twice from the same land, with one of those harvests crawling just beneath the surface. In Australia, the shift toward this system is more than just a new farming method, it's a shift in mindset. It proves that productivity and sustainability aren't mutually exclusive. They can coexist in muddy waters where little red claws gently till the soil beneath a sea of green stalks, quietly rewriting the rules of modern agriculture. When Australia officially rolled out its rice crayfish pilot program, many laughed. The image of crustaceans crawling through rice paddies seemed like something out of a parody. Media headlines joked about claw farming and memes flooded social media. But in the heart of the Riverina, Australia's rice-growing belt, something real was happening. Backed by government funding and bold farmers willing to try something new, researchers launched targeted trials. Sites were carefully selected for their soil, water access, and proximity to irrigation infrastructure. These weren't random experiments, they were the beginning of a quiet revolution. And now, as the first commercial-scale results roll in, it's clear the joke is over. Crayfish in rice paddies may have started as a punchline, but they're ending as a promise. To start. Farmers were trained on how to modify their rice paddies to support aquatic life. Shallow trenches were dug along the edges of fields to create deeper zones where crayfish could take refuge during extreme heat. Inlets and outlets were fitted with fine mesh screens to prevent crayfish from escaping. And stocking densities were calculated down to the square meter. Too few crayfish would make the system unprofitable. Too many could lead to collapse under stress. Every variable was meticulously tracked: water, pH, temperature, ammonia levels, oxygen content, and even the depth of crayfish burrows. Despite the rigorous planning, concerns lingered. Farmers worried that crayfish would burrow into levees and compromise the integrity of their fields. Some feared the additional workload wouldn't be worth the potential return, and others doubted that these tiny crustaceans could genuinely replace pesticides and fertilizers. "We're rice growers, not lobster wranglers," one farmer joked to a local reporter. For the first few months, nothing looked different. The rice sprouted, the water glistened, and if you didn't know what lurked beneath the surface, you'd never guess anything had changed. But subtle signs began to emerge: lower pest pressure, reduced weed growth, clearer water. Occasionally, flashes of red claws would ripple the surface before darting back into muddy trenches. Agricultural colleges began integrating rice crayfish modules into their curriculum. Children who once saw farming as outdated now envisioned careers in modern climate-smart agriculture. Environmentally, the transformation was even more striking. Fields that once emitted methane and drained rivers were now functioning wetlands. Native frogs, ducks, turtles, and beneficial insects returned. Water quality downstream improved. Some farms earned eco-certifications and sustainability credits, gaining access to premium export markets. Globally, the story spread. Delegations from Southeast Asia, Sub-Saharan Africa, and Latin America visited Australia's pilot farms. Countries like Bangladesh and Uganda saw the model as a potential lifeline, offering both grain and protein without degrading land. Australian universities partnered with NGOs to share the method abroad. Back home, agricultural policy shifted. Grants began favoring integrated systems. Urban planners even looked into using rice crayfish paddies as natural flood buffers. And culturally, something deeper changed. Australia's identity as a land of vast monocultures began to evolve. Farmers weren't just growers anymore, they were innovators, ecosystem stewards, and climate problem solvers. So yes, people laughed in the beginning at the idea of farming crustaceans alongside rice, of muddy fields becoming miniature aquariums. But 1 year later, as the yields rose, biodiversity returned, and income doubled, that laughter turned into admiration. Because Australia hadn't just changed how it farms, it had changed how the world looks at farming. And maybe the answer to some of our biggest challenges was there all along, hiding just beneath the surface.